Assalamu alaikum and welcome to the Mathcast with Faria Yusuf. This video is the continuation of Binomial Expansion and Theorem, past papers questions, and we will be doing more questions to reinforce the topic here. So the next question that I have chosen here is from Winter 2016, paper 1, variant 2, and this is question number 4 in the paper. The question says, in the expansion of bracket 3 minus 2x, bracket 1 plus x by 2 to the power n, the coefficient of x is 7. Coefficient of x, so this is the keyword here, it's the coefficient of x which is a 7. So find the value of the constant n and hence find the coefficient of x squared. So first we need to find the value of n and then we will be finding the coefficient of x squared. Let's start working on it. So it's 3 minus 2x bracket 1 plus x by 2 to the power n, and 3 minus 2x, if we expand 1 plus x by 2 to the power n in terms of n, then for binomial expansion I should know that this is going to be 1 plus nc1 x by 2, nc1 is an n, x by 2 plus nc2 x by 2 the whole square. And to get the coefficient of x, because they have said that it's this is the data or the hint that is given to us that it's the coefficient of x which is equals to 7, I will be interested in finding out all the terms in x here. So it should be 3, so it should be 3 getting multiplied by nx by 2, and then it should be 2x multiplied by 1 here. So if we start working on it, I'm going to say that I shall be having here 3 into n x by 2 minus 2x and 3n by 2 minus 2, 3n by 2 minus 2 times x, which then shall be equal to x. So if I compare the two sides, the left hand side and the right hand side, then here I should say that it is going to be 3n by 2 minus 2, which is equals to 7, or 3n by 2 equals a 9, or 3n equals 18, and then n shall be equal to a 6. So this is how I will be finding the value of n here, and hence find the coefficient of x square. That means I need to have the coefficient of x square also. So if I again look at the expansion here, I know that if I should multiply 3 by nc2 x by 2 the whole square, now I do have the value of n. So 3 times nc2 x by 2 the whole square, and also if it is 2x which gets multiplied by nc1 x by 2, this also shall give me the coefficient of x square here. So to start the working, I should say that it's 3 times, I should say that it is 3 times nc2 x squared by 4 minus 2x into nc1 x by 2. nc1 is an n x by 2. N value we found out in the previous part was equal to a 6. Therefore, substituting n by 6, it's 3 times 62 into x squared by 4 minus 2 times 6c1 into x squared by 2 here. The 2 gets simplified. Therefore, this becomes 3 times 62 is a 15 into x squared by 4 minus 6x squared, or 3 times 15 is a 45 by 4 minus 6. That is going to be the coefficient of x squared, and the final answer here shall be equal to a 21 by 4, and also we can say that this answer here can be a 5 whole 1 by 4x squared. So this also can be the answer to this question here. Let's move to the second question. Now the second question says, find the term independent of x. Find the term independent of x in the expansion of 2 by x minus 3x to the power 6. Independent of x, term independent of x, that means I should be talking about the term which is a constant, or x to the power 0, which shall be having a particular coefficient here. So x to the power 0 with a coefficient, that means we are talking about the constant in the equation. Therefore, I should say here that if this is 2 by x minus 3x to the power 6, then to find the term, I should be taking help of the term formula. And the term formula says that it is Tn, which equals Tr plus 1, that equals NCr a to the power n minus r b to the power r, where we know a is the first term, which is a 2 by x, b is a negative 3x, and n value obviously is going to be a 6 here. So with respect to this data, if I substitute all the values here, then Tn, which equals Tr plus 1, shall be equal to 6Cr into 2 by x power 6 minus r into negative 3x to the power r here. Taking all the values on one side, taking all the values or on one side, I should say that this shall be equal to 6Cr into 2 to the power 6 minus r minus 3 to the power r, and then solving for the variable x, this x to the power 6 minus r. So it's 1 upon x 6 to the power 6 minus r into x to the power r here. Again, solving for all the powers of x, I should say that this shall be equal to a r minus 6 plus r. That means from the denominator, when these powers they get shifted to the numerator, their sign changes, so this becomes r negative 6 plus r, or I can say that this value here is going to be a 2r and a minus 6 here. So the term formula becomes 6cr in terms of r, which we do not know. This becomes Tn, that equals Tr plus 1, that should be equal to 6Cr 2 to the power 6 minus r minus 3 to the power r x to the power 2r minus 6. That means only if we know the value of the restriction, we shall be able to find the particular term here. So to get the value of r, we know that the question is asking here for the term independent of x, which means I need to have x to the power 0 here. So if this is x to the power 0, then equating x to the power 2r minus 6 to be equal to x to the power 0. Bases are the same, therefore equating the indices, I should say it's 2r minus 6, which equals 0. It's 2r, which is equals to a 6, and then r shall be equal to a 3. So if r is equal to a 3, then we should know that we are talking about the fourth term here, because Tn equals Tr plus 1. So 3 plus 1 gives me a 4. Therefore, it's the fourth term, which shall be equal to 6C3. R is a 3 here. So 6C3, 2 to the power 6 minus 3 and minus 3 to the power cube and into x to the power 0, which is obviously going to be a 1. 6C3, that's a 20, into 2 to the power cube, that's an 8, minus 3 to the power cube will give us a negative 27, meaning the fourth term here is going to be a negative. Therefore, negative 20 times 8 times 27 will give us 4320. So the fourth term independent of x is going to be a negative 4320. The second part of the question, find the value of a for which there is no term independent of x in the expansion of 1 plus ax squared 2 by x minus 3x to power 6. Now, no term independent of x, meaning there actually does not exist any term which is independent of x, meaning if I do the expansion for the two brackets, then there is no constant in the equation. So for no constant in the equation, again, I shall be using the term formula. And for the term formula, I should say that I should be doing some critical thinking, where I should say that this should be 1 plus ax squared times 2 by x minus x to the power 6 And here 1 should get multiplied by the term which we just found in part 1, which was independent of x. That means this was the constant negative 4320. So if this one gets multiplied by negative 4320, then obviously it's the term which is independent of x here. Secondly, if I have ax squared, then there has to be a term for this expansion which should be having x to the power negative 2. Ax squared times a term in this expansion which should be having the power as x as a negative 2 here. So if I get to multiply both of them, obviously x squared into x to the power 2, that becomes x to the power 0, which is a 1, and the term again becomes independent of x here. So to solve that, again I will be using the term formula for 2 by x minus x to the power 6, and using the term formula here, we already got the term formula from the previous part, which said that it has to be x to the power 2r minus 6. In this part, we were saying it was equal to x to power 0, whereas in part 2, we should say that this has to be equal to a negative 2. So x to the power 2r minus 6, which is equals to x to the power 2. Solving for the indices, it's 2r minus 6, which equals a negative 2. 2r equals a 4, therefore r will be equal to a 2. So if r equals a 2, then for this expansion here, r is a 2 and it has to be the third term. I should simply be substituting r as 2 here. So substituting r as 2, I should say now that this is going to be a negative 4320 plus ax square into 6c2 into 2 to the power 6 minus 2 minus 3 to the power 2 and x to the power 2 times 2 minus 6, which gives me x to the power negative 2. So x to the power negative 2 here, which when multiplied by ax square, obviously x square into x to the power negative 2, they both get simplified, and I shall be having here negative 4320 plus 15 into 16 into 9, that gives me a 2160 times a, and this shall be equal to a 0. And again repeating, this is equal to 0 because the question has said that there is no term independent of x, meaning there is no constant in the equation. Therefore this should be equal to a 0. So equating it to 0, then solving it further, I should say it's a, which is equals to a 4320 divided by a 216, and with the 2160 here, a shall be equal to a 2 over here. So this is how I shall be solving for this question. Moving to the next question. And this question has been taken from Winter 2022, paper 1, variant 1, and this is question number 4 in this paper. And the question says coefficient of x square in the expansion of 1 plus 2 by px to the power 5 plus 1 plus px to the power 6 is 70. So they have given us the coefficient of x square. It's the expansion here shall give us a 70x square. So we need to find the possible values of p. So if we are supposed to get the possible values of p here, then with respect to this possible values of p, I should be having here 1 plus 2 by px plus 1 plus px to the power 6. Solving for 1 plus 2 by px to the power 5, applying the term formula because I need the coefficient of x square, I should say it's Tn, which equals Tr plus 1 NCr a to the power n minus r br. N here is a 5, so it's 5cr, a here is a 1, and then b here is a 2p by x to the power r. I need the coefficient of x square, so it's very much clear that my restriction has to be a 2 here. So with this restriction to be a 2, I should say it's the third term, t3, which shall be equal to 5c2 into 1 and then 2px to the power of 2. 5c2 is a 10, 2 square is a 4 p square, and this is going to be the coefficient of x square. 40 over p square shall be the coefficient of x square here. Now solving for 1 plus px to the power 6. 1 plus px to the power 6. Now here again I shall be using the term formula, and with respect to the term formula, n value is a 6. Substituting n as a 6, I should say that it's Tn, which is equals to Tr plus 1, which equals 6Cr into 1 into px to the power of r here. R here because we need the coefficient of x square as given in the question. So substituting r as 2, I should say that it is a 6c2 into px the whole square. 6c2 is a 15, p square and x square. So I have the values over here. I have all the values here, and combining the two for the coefficient of x square, I should say that it's a 40 p square. It's 40 over p square plus 15 p square as the coefficients of x square, and this should be equal to a 70x square. Solving it further, I can say it's a 40 over p square plus 15 p square, which shall be equal to a 70. Or simplifying and taking the LCM, I should say it's a 40 plus 15 p to the power 4 over p square, which equals a 70. And then taking this p square, multiplying it with 70, I'm getting a 40 plus 15 p to the power 4, which equals 70 p square. I can see here that I'm getting a quadratic disguised equation with the highest power as 5. My equation here becomes 15p to the power 4 minus 70p square plus 40, which equals a 0. Changing it to quadratic, I will have to assume that m is equals to p square, and therefore m square will be equal to p4. That will give me a quadratic form, which is 15m square minus 70m plus 40, which equals a 0 here. And then solving it further, my m value for this quadratic equation comes out to be a 4 and also a 2 by 3. M was actually equal to p square, therefore p square equals a 4 and p square equals a 2 by 3. Or I can say p is equals to a plus minus 2, and p can be equal to a plus minus under root 2 by 3 here. So there are 4 values of p, plus minus 2 as well as plus minus under root 2 by 3. So these are going to be the possible p values for this particular question here. Let's move to the next question. And this question has been taken from Winter 2022, paper 1, variant 3. And this is question number 3 in the paper, where it says find the first 3 terms in the expansion in ascending powers of x for the expansion of 1 plus 2x to the power 5. So it's a pretty easy question. We just have to do the expansion here. It's 1 plus 2x to the power 5. So 1 plus 2x to the power 5, it's equal to 1 plus 5c1, and c1, n is a 5 here, so 5c1 into 2x plus 5c2 into 2x the whole square. 5c1 is a 5, therefore I should say it's a 1 plus 5 into 2x plus 5c2, which is a 10, and 2 square is a 4, so it's a 4x square. And the final expansion up to 3 terms is going to be 1 plus 10x plus 40x square. So this is just a simple 2-mark question. Part B. Part B is also to find the first 3 terms in ascending powers of x of the expansion 1 minus 3x to the power 4. So 1 minus 3x to the power 4, our n value is a 4. So this shall be equal to 1 minus 4c1 into 3x plus 4c2 into 3x the whole square. 4c1 is a 4, 4 times 3, that gives me a 12. So it's 1 minus 12x plus 4c2, which is 6 here, times 3 square x square, that will give me a 9x square. So my final expansion for this part shall be 1 minus 12x plus 54x squared, and this is going to be the answer. Part C. Hence, find the coefficient of x squared in the expansion of 1 plus 2x to the power 5 and 1 minus 3x to the power 4. Here, I have done the expansion for 1 plus 2x to the power 5 in part 1 and 1 minus 3x to the power 4 in part 2. So I should simply be using that expansion over here. So it's 1 plus 2x to the power 5, which was 1 plus 10x plus 40x squared, and 1 minus 3x to the power 4, and that was 1 minus 12x plus 54x squared. So again, I just need the coefficient of x squared, so I have to be particular in only getting the terms involving x squared, not wasting our time in getting the whole expansion done here. So just to get the terms in terms of x squared, I should say it's 1, which should get multiplied by 54x squared, 10x, which should get multiplied by negative 12x, and 40x squared multiplied by 1 here. So all the three terms, they are having they are having x squared with them. Therefore, it should be a 54 minus 120 and a plus 40 x squared, and the answer here is going to be a negative 26x squared. So this is how this question needed to be done here. So let's move to the last question. And this question has been taken from Summer 2018, paper 1, variant 2, and this is question 1 in the paper, and it says the coefficient of x squared in the expansion of 2 plus x by 2 to the power 6 plus a plus x to the power 5 is 330. So they have given us the coefficient of x squared, which is a 330. So we need to find the value of a, meaning if it's the coefficient of x squared given to us, then in the expansions, I should be having the term involving x squared. So let's start working on the question. So n value, if I solve for 2 plus x by 2 to the power 6, we know that our n value here is a 6, a is a 2, and b is an x by 2 here. So b is an x by 2. Applying the term formula, it's Tn, which equals Tr plus 1, 6Cr, n value was a 6, so I've applied the n value as a 6, 6Cr into 2 to the power 6 minus r, and x by 2 to the power r. I know I should be having x as a square, therefore it's very much clear that the value of r needs to be a 2 here. So it's 6c2 into 2 to the power 6 minus 2, which gives me a 4. 1 over 2 squared and 2x squared. Solving it further, it's 6c2, that is a 15, into 2 to the power 4 divided by 2 squared, that leaves me with 2 to the power square into x squared, and then this becomes 4 times 15, which is a 60x squared. So 60x squared should be the answer for 2 plus x by 2 to the power 6 with a term in x squared. Let's solve for a plus x to the power 5. So for a plus x to the power 5, our n value is a 5. Again, applying the term formula, Tn equals Tr plus 1, which equals 5Cr, a to the power 5 minus r, and then x to the power r here. Again, it's just this x. So I should say that my r value has to be a 2. So applying r as a 2, I should get the third term, and this should be equal to 5c2 into a to the power 5 minus 2, giving me a cube and x squared. 5c2 is a 10, so this becomes 10a cube and x squared here. So I have both the terms in x squared. So I should be now adding both the terms and equating it to 330 x squared. So adding both the terms, it should be a 60 plus 10a cube x squared, which equals a 330 x squared. And solving it further, 330 minus 60 gives me a 270. So 10a cube is equal to 270. That gives me a cube, which equals a 27. Or finally, I can say that a is equal to a 3 here. So this was again a simple question, and I have tried my best to explain all the critical questions to you so that the concept gets clear, and wish you all the best with binomial expansion and theorem. And let's meet you in the next video for the next chapter, which is going to be circular measures. So Allah Hafiz and bye bye.